We have built our automated certificate authority for our Devlab, and we were successful in deploying the new SSL certificate to our Proxmox virtual environment server using Ansible. The server accepted the certificate and rebooted with it, but the clients, like LibreWolf as we have seen in the previous episode, did not like it. Today we are going to change that and to automate that change so that we can deploy certificates that are trusted by default by most of our systems. The concept of chain of trust is as old as society. The same concept was used when an ambassador presented papers sealed by his king's seal to the other king, which made the other king trust the seal of the ambassador. In cryptography, or what is called public key infrastructure or PKI, when a certificate is marked as trusted by a certain client, all certificates signed by that certificate are trusted automatically. And all certificates signed by other certificates that are signed by a trusted certificate are marked trusted automatically. So, to trust all our certificates that we generate in our certificate authority for all our services on all our servers, we need all our clients to trust our root certificates. That is the theory, but the practice might differ. And we will see some of the examples of that difference during our exploration in the Devlab. All our clients come with their own list of trusted certificates, which are certificates that we did not explicitly trust. They are signed by parties that we might not have ever heard of, and consequently, we have never explicitly trusted. This applies to the trusted certificates of operating systems, of browsers, of all types of internet clients, and of cryptographic libraries that are deployed to our systems by the services we use. For example, this is LibreWolf, which is a custom version of Firefox focused on privacy, security, and freedom. This is how they present themselves. Let's look at their trusted certificates. If I go to the settings page, privacy and security, and I scroll down, I see view certificates here. And if I look at the authorities they trust, I see ACCVRAIZ1. So that's a certificate authority apparently in Spain. Notice that this certificate is signed by itself. So it is a self-signed certificate, just like the certificate we created. Actalis Authentication Root CA. Those people are in Milan, and also this certificate is self-signed and is valid for 19 years. Affirm Trust. This certificate is also self-signed and is valid for 30 years. So LibreWolf or somebody made me trust this certificate for 30 years. TON Trust Root CA. Agence Nationale de Certification Électronique from Tunisia. TN is Tunisia, I think. I have never heard of these people. I have never explicitly trusted them. I have never, for example, heard of Beijing Certificate Authority. Also self-signed. Let's look at the operating system. This is the settings of my new Fedora install. And it came with all types of the certificates. First, we see the usual suspects. And we see also the Beijing Certification Authority. If I display this here, I see that it is self-signed also. The same certificate. Here, also self-signed. So these people have two self-signed certificates imposed on us. Not one root certificate, but two. So what happens if I decide to take control of the trust on my computer and untrust some of these people. Untrust bypass. Who are these people? Bypass. Another self-signed certificate authority that it's in Norway. Norwegian certificate authority. So what happens if I decide to untrust these certificates? The only result that would happen is that when I visit something signed by these people, I would get a warning that this certificate is not trusted, which is what I want. I have explicitly untrusted them. What happens if I add a certificate here? Like if I add a certificate, let's say our certificate, which is a self-signed certificate, like all of these certificates here. What happens is my certificate will be trusted on this machine, and if I add it here in LibreWolf, it will be added. For example, I was testing adding my own certificate. Let's try adding it. I want to trust it explicitly, and now it's added. Is the Devlab. Now it's the Devlab certification authority, and it's just like any other certificate that we have created. Valid for 10 years by default. This is how we take control of the trust in our systems, and but that is not good enough for a Devlab. For a Devlab, we need to automate this process, and this is what we will do now. Let's look at the code. You will notice that I merged the two base roles that we had earlier, the base Debian and the base Fedora roles. I merged them into a base role. The reason for that is I thought those roles are growing and they are becoming fat, and that will make them a lot harder to maintain. And they had a lot of common tasks between them with some differences. So what I did is I had all the common tasks in their own task files, and I have the Debian special tasks in a task file and the Red Hat special tasks in a file. This is the Debian task file. We see that we upgrade all the packages. Then we move to the certificate part. Here, we copy the devlab ca.bem into the specific path that Debian wants. And not only that, Debian requires the file to be .crt. Originally, I thought it required a CRT file, but no, Debian treats this file as if it was a CRT file, but it requires the extension to be CRT. Fedora does not have that requirement, and it can understand .bem and treat them well. So we renamed the file and we ran the command to update the certificate. This command is different in Fedora and Red Hat systems. Then we handle Mozilla applications, Firefox, Thunderbird, and all the applications that are derived from them like LibreWolf. Those applications use a custom library that was developed by Mozilla. It's called the Network Security Services Library, or NSS. This library uses a certificate database, and it has the same name by default in all Mozilla browsers and applications. So the name is cert9.db, and they put this database in the profile of their users. The profiles are normally in the user home directory under .mozilla or .firefox or .thunderbird or .libreWolf or something. So I'm using the find module in the Ansible built-in collection to find all the folders that have this database, and I will run a command to add the certificate to them. However, before I run the command, I need to install the library that Mozilla uses for that. And the library name is different between Debian and Fedora or Red Hat systems. The command is this command, and the command is the same between Fedora and Debian, and we run it when we have files, and we loop on all the certificate files that we find here. For Red Hat, the task is the same. The difference is only we use DNF here, we use a custom path here. Although I could have left the file to be .pem, I prefer to make it .crt for consistency between the systems. And I think now we can update the dev machine. So the dev machine role has only the base role. We will test the base role on my dev machine. Let's see. There are some upgrades. The packages are already installed. So we trusted the certificate and we added the files to the trust in all browsers. And those are the what remains from, yes, and we added also the Node.js task so that we, in all our development machines, will trust the certificate if we run Node.js on them. You will also notice that I added two hosts here to the hosts files. I'm adding these here because we still do not have DNS enabled in our network. We will set up DNS and name resolution, I think, in the second or third episode when we go back to the Debian router. So I'm defining devlab.devlab and gitlab.devlab, and my domain for my devlab will be .devlab. So if we look at the development machine now, and I try devlab.devlab on the Proxmox port, I see I got a trusted certificate, but Mozilla warns me that this certificate issuer that is not recognized by Mozilla, which is fine. I accept that. And I see here my certificate, and I see the chain of trust up to the root certificate. And you see our certificate is the same. Our root certificate is self-signed as all of the self-signed certificate we have seen. It worked for us now because we are doing Mozilla, but on Chrome it is a bit complicated. And it worked on Linux. If we want to do that on Windows or on FreeBSD or on Mac or on other systems, the process will be a bit complicated. And that is the challenge of managing a certificate authority, having your own certificate authority, because you need to deploy your certificate and establish the trust on all the machines by default. So you either need to have your own distribution, or you need to have your own templates for the machines with the certificate, with the root certificate built in them, or you need to do that in by Ansible. I'm not doing it for the other systems right now because of time constraints. If somebody needs them, please write to me in the comments and I will be happy to look into that. If we are not doing it for other browsers, I use Firefox or LibreWolf all the time. So for my Devlab, I am okay. For Chrome, I'll show you the Chrome problem. So this is a new install of Chrome. I personally do not use Chrome unless I need to test something. I do it on Chrome. So let me look at its settings and privacy and security and manage certificates. So here you should be able to manage your certificates, but it says you have certificates on file that identify these certificate authorities, and you see an untrusted certificate authority. Doesn't Chromium have a list of certificate authority? Yes, it does, but it does not allow you to manage it in the UI. And I'm not sure you can manage it in another way. If you know a way to untrust a certificate in another way in Chrome, please let me know. I think Chrome was using NSS until recently, and I found comments in their documentation about them using NSS but changing things in it. I don't know if they have any tools to manage the certificate other than the interface, which is missing. We can, of course, try to import certificates, but we want to do that in Ansible. We don't want to automate that, not to import a single file on every Chrome browser that we have. I still did not look into that, and I think I'm not going to do it until unless somebody needs it and request in the comments. So in that case, I would look into it. For me, in my Devlab, I always use, as you see, a Firefox or a derived browser from Firefox. It's not easy to run a certificate authority and to deploy certificates to all the client systems. And even with automation, with things like certbot and the solution that Let's Encrypt are creating, that helps you for the server side. Like, it's not for the client side. The client side remains challenging. You have to add, for example, for Node.js, you have to add the certificate yourself. We will see when we do GitLab that you need to declare the certificate authority in every call to GitLab when you want to use GitLab under SSL. And that's why I did GitLab before we do SSL. I want to do GitLab now. You will see that I added these tasks after we run GitLab, the GitLab role. And before we configure GitLab, I added tasks to get a new certificate. That is the SSL server role that we have seen it before. Then we need to copy the certificate to a specific folder. We need to create a directory, the SSL directory, and copy the certificate to a specific folder in that directory. And we copy the chain and we name it also in a specific name. We copy the key and we name it in a specific name, which is the domain name that we are using, .crt. And then we update the certificates settings if needed, and we loop through the configuration file, and we do some updates which are here. So if external URL, we define the external URL, and I changed it in the variables file. We set Let's Encrypt to false since we are using SSL, our own SSL. And we ask Nginx to redirect to HTTP. So we ask Nginx to redirect HTTP to HTTPS. Then we run the GitLab configuration, and in my tests, I noticed that if you reconfigure GitLab before stopping it, you should be able to do that, but it did not succeed on my machine. So I had to stop GitLab and reconfigure it and start it again. And then we wait for GitLab to start, and that takes about 30 seconds. The machine boots immediately, but the GitLab services take about 30 seconds on my machine to be ready and to start serving requests. And then we run the GitLab config role, which creates the group and the repositories that you want to deploy. I still did not test this playbook on a new install. I'm testing it on my install, and because it takes time, I have already run it. We get a certificate authority, like it's signed by our certificate authority. This is our certificate, and this is the certificate authority, and it is trusted in the system. It's trusted by Firefox, and it is trusted in the system. And we managed to do devlab here and gitlab.devlab here, because we have set up our these two records in the hosts file of this system. As we have seen, it is easy to create a certificate authority. It is very challenging to manage the chain of trust and to propagate the chain of trust. We have seen the challenges for propagating the chain of trust on a single party, like there is no third party or second party even. I'm doing it in my lab or for myself, and Ansible is very helpful, but it is still a challenge. That does not mean that propagating this chain of trust will be easier with other systems. It's just hard to get trust. You need to work hard to get trust. Having our certificate authority operational in our Devlab is essential for many of the tasks that we will need later on, because they depend on it. For example, we will need it to create a Docker registry so that we can build Docker and Swarm containers inside our Devlab and store them inside our Devlab and use them as a GitLab runner. So that will be my next step. After that, we will look at the Linux router, and there are amazing ideas here. I enjoyed working on them very much. I think you will enjoy them. One of them is called WireGuard, as you have never seen it before. Also, I plan to run a Java dev machine and a .NET dev machine, possibly, not sure, an Android dev machine. And then I'm thinking of closing this season and moving to a different hypervisor or a container orchestrator if you want to do that. So that will depend on the audience feedback. If I get audience feedback, I'll do it. Otherwise, my preference is OKD. I want to thank all the people who are following me and who have subscribed and liked my videos and left me comments. That makes me feel that my work has value to some people, and that gives me the motivation to move forward. Thank you very much, and please follow me, and see you in the next episode.